Hey guys, what's up? Eddie Aho here with KissAnalog.com and another meter review. This is a Redfish, okay, from Sunco. I think Sunco's the distributor, but this Redfish Instruments, it's a California company, but the meter's made in China. Now, I'm going to compare it to this Fluke. This is made in Malaysia, but it's a 117, like 115, 117. They're kind of similar meters, but these guys are similar in size. Both rugged cases. I think they're both, made for like electricians. This comes with the hanger, the magnetic hanger, the strap with Velcro on the back. Very nice meters. Okay, so we're going to compare this guy to this Fluke, and it's just a little bit bigger than that Fluke. And it's probably just a little bit smaller than this Fluke, the 18B Plus. So this is a Chinese-made one, and this is also Chinese-made. So I think we're going to compare these two guys, okay? Now, right off the bat, what I'll say is these are both safety certified, where this Fluke, it's a CE certification, okay? But the price of this falls in between these two. It's probably a little closer to this. So I thought, well, compared to the Fluke 117, I like to compare them to a Fluke that people recognize, because then they can see, what it looks like and how it performs compared to a meter they might know. All right. And also in a similar price range. Well, in this case, similar price range. So besides safety certifications, what I want to say is this is category 3, 600 volts. Okay. So category 3 is like working over there in the panel, Category 4 would be working on the other side of the panel, like out at service entrance where power comes into the house, where there's a lot more energy. So this meter is category 4, but it's also category 3 up to 1,000 volts instead of 600. So it's usually in category 4 meters, they'll go 600 volts category 4. So there's more energy in category 4. That's why the lower voltage. But then in category 3, because it can handle the category 4, it can handle a higher voltage in category 3, 1,000 volts versus the 600 volts. Also, you got 4 terminals. You got microamps and milliamps on this one, where on this guy, you just have amps. Okay, so 3 terminals. So just some of the things right out of the gate, safety certifications, and some of the basic capabilities. This guy also, besides doing, I think everything that meter will do, it'll also do, this one has volt alert, okay? So this one has the non-contact voltage, where you can, get close to here, where this guy here is volt alert. It's the same thing, it's just a different name Fluke calls it. So, but this guy also does temperature, and where that one doesn't, the 17 does not. I think, I'll have to check, but I think the 15 does temperature, but not the volt alert. And so that was a trade-off between the 15 and 17. I believe that's the truth on that guy. But this guy, one of the special things that this one has is also has logging function. It has Bluetooth. So it has this little red button for logging. So that's pretty cool. It's both 6,000 count meters, both true or minus, obviously. So yeah, this guy does have the relative function. They both have hold. They both have min-max, and we're going to compare the backlight displays and all that. This one comes with some nice leads and a temperature probe as well. So we'll check that out. All right, let's come over to the bench, take a closer look. All right, guys, I'm speeding up the box opening process. Here's the box. Okay, Bluetooth, that's really neat. A lot of good features for both HVAC, electrician work, and just for bench work. Here's your Bluetooth app. That's what it looks like. Here's your measurement tolerances, your accuracy. So 0.5% for DC voltage. That's very nice. +2 counts all the way down. So you can look at those numbers there. And all the other features, okay? It has IP54. And look at this, ETL safety rated. So safety rated third party. Let's pull this meter out. All right. Look at all the goodies. Nice soft test leads. Those look really soft to me. Very sharp points on those. And you get the alligators, and they're the threaded ones, so they don't just fit with friction. They actually threaded on, so that's nice. Now this looks good with the red and white, so easy labeling for, you know, using there. Make sure you get plugged in right, and your 9-volt battery. So let's check out. Oh, and look at this, a nice heavy duty magnet holder with a hole for hanging on screws or whatever, and it's velcroed to the hanger in the back. So let's check it out. All right, I'm going to speed things up. So I undid this guy to get to the battery. There's your kickstand, and there's your ETL rating: Cat 3 600 volts, Cat 4 1000 volts. So there you go, third-party safety tested. And there's your little hook for your Velcro. That is looking really great. And we got a spongy thing to hold the 9-volt battery in so it's not rattling around. Okay, there's a nice clean compartment. If you know, 9-volt batteries don't normally leak, but you don't have anything that's going to leak down into your board there. And the channels are very wide, you know, they go down around here. So we like to see that too, right? Now there's another door. I've got that door, so it's coming off too. It tells you what fuses to use, and there they are right there. So you got the inserts for the threaded screws, so that's great. Okay, now let's open that bad boy up because I knew you'd want to see it. So here's your shield. Okay, you can see how it's going across, shielding your chipset right there. And you've got these crystals and a little buzzer. So you got some tantalum capacitors. I mean, a lot of MELF resistors, those round resistors. So no aluminum electrolytics in this. It's looking really great. You got a gas discharge tube instead of MOV, and you got your 2 PTCs. Here's your shunt for reading current. Okay, and then they run a wire instead of a big trace on the board. They run a wire up to the fuse to go across the fuse, and you got some more MELF resistors down there. So construction looks great. Everything looks good. You got your protection diodes here, your MELF resistors here, your high voltage resistors there. So there's 1, 2, 3, 4, 5 of them. Okay, and yeah, look at all the MELF resistors. So yeah, looks very good. And by the way, again, the channels are very deep that go down in here. And this rubber, you know, it's part of the plastic, so it doesn't peel off, but it is pretty heavy duty. It has a nice feel to it too. So, and the cutouts here, you know, makes it fit your hand really nice. So yeah, like the construction. This is the 14-bit A-to-D processor. It gives up to 6600 counts. There's a plastic nub that kind of helps find the board. And here's some MELF resistors. There's a bunch of MELFs on this thing. A ceramic capacitor, a couple of ceramics. There's a tantalum capacitor, that big yellow one. Yeah, everything looks pretty clean. Okay, there's a clock chip, the SSTS. And this guy here, this HY part, he's a LED display driver. There's some parts, LED that was not installed up in the right corner there. And there's our Bluetooth part, the PAN 1720. That's Bluetooth 4.0. And big old ground plane, it looks like. There's a non-contact voltage antenna up here somewhere. Might be on the opposite side of the board. Maybe this ground plane supports that. And that silver cylinder is one of the crystals. There's another crystal, another silver cylinder, which is transistor and ceramic capacitors. We're back at our chips again. Hello, plastic nubs help find the circuit board. And then we have this header. That's for programming, I would assume. And there's a U4, that's a voltage regulator, another tantalum capacitor. And there's our battery connections. You know, there's a little bit of solder splatter. That's probably the worst I've seen on the board. Everything else looks clean. Couple of transistors. There's a protection TVS diode. Look at the copper work, all that ground plane, kind of a grid pattern. And we got a fuse carrier down here. These are the protection diodes. There's like 5 of them. Another one of those plastic nubs right there, hold the board. More melt resistors, just a bunch of them on this board. There's our fuse carrier. More melt resistors down here. Yeah, just a lot of melt resistors used on this board. Just probably the most I've seen, I think. And there's our current shunt. Big long thing there. And look, there's a protection diode. That is a spark gap part, and it's a brown, green, red. So 1500 volts. Oh, there's PTC. PTC number 2, it says. Oh, there's another one up there. So there's 2 PTCs. Okay guys, this is banana lug terminals, kind of typical of the split type. They look like they're well done. And there's board rev 2.1, 2016, February 18. All right, and this is a UL 94V0 fire retardant rating. That is pretty typical of a good board. And that must be from the board house, this thing. Looks like KT. Anybody familiar with that one? Leave in the comments. And there's a spring for the shield. Let's get a better look at that. Okay, there's a spring. It's tied to the ground plane, touches the back of the housing, and it grounds the shield to the ground plane, so it keeps it one voltage plane. All right, we got it back together. Let's turn it on. Oh, nice. Wow. Big digits, huh? Big display. Okay, let's turn on the backlight. There we go. I like that backlight. Nice, big, bright, evenly lit. There's our Bluetooth icon. So, yeah. Okay, there we go. Got more functions there. Okay, I have to look at the manual to see how to keep this on, but chances are probably hold this down. Oh, I'm in NCV. All right, so here is the Redfish meter. Just go through the user manual real quick just so you can take a quick look from 2015 if you caught that. You can pause, of course, and look at anything you want. 1-year date of purchase warranty. There's Santa Cruz, where you can register it. Santa Cruz, California. Safety standard here. Talks about the cat ratings. So here's some warnings that are always good to read. Okay. Here's the ETL Safety Agency, the third-party safety group that tested for these standards for the Cat 3, Cat 4 that's listed there. Okay, they talk about the Bluetooth, and by the way, it's good to hit that little button, turn it off when you're not using it, because that'll run down the battery. This little button right here is the record Bluetooth button. So there's the Redfish display. Here's the, okay, like I say, you can of course pause this, look at anything you want to. Breaks down the display. Okay, there you go. Okay, this talks about measuring high voltage, 1000 volts, be careful, so on. Current readings, Okay. Pause that there for a minute. Real basic percentage. So there's a 0.5% for DC. Pretty common for 6,000 count meters. Okay, there's Redfish information. Hey guys, so I've got 3 meters here. I added the Southwire. It's one of my favorite meters. high count meter compared to the 6,000 count meters, just so we can kind of have a voting. If measurement from one is different from another, then we can use the south wire to kind of, you know, set the volt. So let's go to DC volts. Now this guy, because I think it's meant for HVAC, first goes to AC. So the function, just want to point that out because this one has a different setting for AC and DC. Okay, so we'll come over here first, and I was just noticing my power supply is already turned on. So it's 3.3 volts, obviously. So 3.299 or 8 or almost 3. And so, yeah, this one, these two guys probably agree a little bit closer. Okay, now my power supply, I'm going to switch around, okay, just so you can see how fast they move and see what they look like. They're all going to be within tolerance. It's with DC voltage, I think it's 0.5% with these two, and this guy is higher. I forget what it is, but anyway, the tolerance isn't going to be really the thing. I just put it up there just to have one more meter to compare, but mostly, you know, the speed and what they look like when they change. So remember, the last digit is the least meaningful because, you know, they usually say 0.5 plus 2 digits is what I think this one is. I think this one might be plus 3. I'm not sure. I gotta look at spec again. But I think these two guys are really, they might be the same. And then there's this one, okay? But they're all so close. Okay, that's 2 volts. Go back to 10, just go back and forth. And then I'm gonna go down to another voltage, 3.3. And okay, my power supply is set for 32, so 31.9, just slightly less. This guy might have just rounded up, but anyway, like I say, they're all within tolerance. Now you notice that some of them, when they switch ranges, they blank, they might go OL or something like that. So here, let me go from 5 volts to 31 or 32. Okay, I'll go back to 2 volts. Okay, now I'm going to go up to 32. Okay, just kind of show you, you know, the difference between them, okay? I'll just kind of move around so you can see how fast they settle in and that kind of thing. All right, so that's what the voltages look like, okay? Now you notice this one has an extra digit because it's a high count meter. All right, I kind of forgot to mention, but I just have these meters all tied in parallel, and I've got like this one, you know, one leg in this one leg in this one, and the voltage coming in, one leg in this one leg in this one. So these two guys are kind of balanced. And this one's semi-balanced too because, you know, the way I've got them plugged in. Okay, so now I've got AC voltage. It's not turned on, so let me turn on the output. All right, and here I'll turn it off. All right, so I'm just kind of showing you how fast it responds, okay? Okay, I set it for 20 volts, and you know when I set this, it's not, you can tell it's not, it needs to have kind of a load to get the voltage just right, but anyway, this is probably close. Okay, and here, let me try this one. just kind of give you an idea what it looks like, okay? Now, you know, you see the AC symbol down here. We see the AC volts and also the high voltage lightning kind of thing there saying, hey, high voltage. And, you know, so these two have bar graphs. You know, bar graphs, maybe in a meter like this where it's fast and it's high count, it might mean something, but most of these lower count 6,000 count meters, the bar graph's not much faster than the display. And I don't know if you guys, let me know in the comments, you guys like bar graphs. It's kind of a holdover from years ago where, you know, so anyway, here we just have larger digits instead. So what do you like better? All right, guys, let's measure some microamps. So I've got the current coming into here, coming out of here, going into the input of the Fluke, out of the Fluke, input of the Redfish, out of the Redfish, back to the, I'm using a generator, okay, function generator or ARV generator, just so we go real low in current. And now these guys, this one and this one has microamp scale. This one we just have an amp scale, okay? So, I mean, look at this. I've got it dialed all the way down to 1.6 microamps. Now I'm going to just bring it up. I'm going to bring it up kind of fast because I think that was impressive. And look, I mean, they match each other pretty well. So I'll bring it up faster. Okay, now this one goes well because it's a high count meter, but it looked like about 4,000, whatever. It's interesting. This guy's still giving us microamps, okay? And if I go up a little higher, this meter is going to start complaining. So let's go to milliamps. Now, with milliamps, the burden resistance, you know, the resistance the current sees as it flows through the meter, that's how the meter picks up the voltage. It looks at the current going through a resistor and says, oh, you know, here's the reading. Now, when we go to milliamps, that burden resistance is smaller, so now more current flows, and so now they're up to 30 milliamps, that guy can see it. So now if I drop it down, look, right there, it drops out. So it's good to down to about 50, you know, 20 milliamps maybe. And this says 19 with 3 digits, 20 with 2 digits, and here we just have 23. And that last digit's the one that's the least, you know, I mean, you can't really count on that too much. Okay, so I'll just go up. I mean, that was just interesting. A lot of people want to see what small current readings are like, so, you know, there we go. That's your small current readings. You know, we're up to about 55 milliamps, and that's as high as I can go with that generator. So, but yeah, there you go. So we can see really small currents. You know, higher currents are going to be easier to read, right? All right, just taking a couple of my banana jacks I've been using, and we're in continuity. So it gives you the ohm reading. It says 0 ohms. That's pretty darn good. And you can hear how loud it is, the tone of it, how fast. The Fluke's very fast, which, you know, being super fast isn't a necessity for me. It's accuracy. But anyway, oh, let's go to continuity over here. Okay, that's ohms. This one we got number of functions here. Whoops, I think I passed it up. Okay, there we go. There's a little sound thing next to the Bluetooth guy. My battery's low on this guy. This meter's been sitting around for a while, guys. Sorry, I lost track of it and then I found the box. You can tell it's very fast. It's got a different tone. And it goes to 0, which is interesting. Okay, so there's our continuity. All right, guys, we got an AC plug. Let's go non-contact voltage, or volt alert if you're there. Now this one has a high and low. I had one of these meters I had to return because every time I touched it, it would just it would just go off. See how it's just going off? But now I have to touch it up here to do it. Before, I'll let go of that cord. Yeah, the high setting is just kind of crazy. But anyway, so it says it's high, and we get a little red LED, okay? Now this one, did I hit a button? I think I hit one of these buttons up here. Okay, see the 4 bars? EF, or electromagnetic force, I guess. So we got 4 bars, and if it's a weak one, it'll be 1 or 2 or 3 or 4 bars. But the Fluke, it has high or low. That's it. Oh, look, I lost my strap. Hey, I left that on there just because I thought it's funny. They put the strap saying, hey, you can spend, I don't know what it is, 40 bucks. I did a video on this one time, get one of these straps, and it fits in this guy. With this one, we get the magnetic hanger with it, so that's pretty cool. Oh, and by the way, just to show you that what other people do, Southwire gives you a nice big magnet too, with the little hanger for a nail or something. Also Velcro strap with the tie. So yeah, with this one, I think it costs you 40 bucks or something like that. You have to check it out. But yeah, I did a video where you can buy ones very similar to the ones you get for, I think they're like 10 bucks. All right, we're gonna need some leads, so let's pull them out. See how these guys kind of, look, they're kind of folded up there. They're not silicone, so they're going to have some kind of shape to them, right? But all you have to do is kind of pull them out and see how the shape starts going away. So these guys are fairly soft, not silicone, but PVC style, okay? And they have the little caps here, which are nice to keep on, keep them from getting flattened out if you put them in the case and they get squished. But these are for the Cat 4 rating, so when you're going in the panel, and you see these guys are not easy to get off. Okay, they come off. There they are. I think maybe it's just the first time, I don't know. But anyway, there's the threads for these guys up here. Okay, that's where they get threaded on. And these guys are very sharp. Okay, now the Fluke. Now, you know, I've made fun of these, and I've had these out of the case a number of times because I've used this meter before, but here, let me pull these apart. Trying to get the probes here. Now, in my hand, I can feel how stiff these are. Maybe you can see that right there, how I'm trying to bend it, and it just goes back to shape. So even though I've had these guys apart before, those were brand spanking new. I just took them out of the case. So anyway, yeah, you can see, look, I can stretch it, and I mean, you know, I can straighten them out, but I can feel how stiff these are. I think everybody knows that's used Flukes know how stiff they are. You can see how the probes don't want to straighten out. I mean, I'm afraid I'm going to just, you know, bend the wires too much inside there doing this all the time. So, but anyway, that's them. And so these are bent there as well, but they, in my hands, I can feel that they're softer. There's nice, you know, yeah, I mean, these are soft enough that when you bend them, it takes some of the tension out of them, right? So these are hard plastic up here. The gray's kind of soft, so the black and red's hard. And with the Fluke, first of all, these guys, it's probably why it's Cat 3, one of the reasons, but I think they sell these with the Cat 4 meters, but these things just come off so easy. And then, you know, but yeah, they're sharp. They're not threaded. But yeah, there you go. We're going to pop those guys off. Try not to lose them. And there's the tips, okay? So they always put these collars up here to keep your fingers from sliding off, you know, when you're trying to push against contact. So yeah. Now these, the Flukes they do have a nicer soft texture. Kind of a, it's not really soft, but it's just grippy. Where this is a hard plastic. So in that sense, I like these, but man, I just hate their leads. All right, so we're gonna do a diode test, okay? So we're in diode mode. See the little diode over here? And this is a big old transistor, and this pin here is obviously tied to the case. These two have a little isolation ring around them. So I'm gonna go to base with the red one, And I should forward bias that to the, yep, to the collector. 0.4, and you hear that chirp? Listen, little chirp. Now, some people like that. I mean, I actually like that too, especially when it's a nice quiet chirp. But for some reason, a lot of the newer meters don't do that anymore. So that's, you know, too bad. Now, so if I reverse the leads, it's going to say OL. In this case, gives me forward voltage, and it does it quick. Okay. Oh, and by the way, when I push these leads in, they go in really soft, really loose, and then they clunk, you know, clip in. And the Fluke kind of does that too. Yeah, they kind of do that too. Similar kind of feel. Okay, red on the base. And touch can. Oh, let's go to the diodes. Okay, there's our diode. And no beep or chirp. I'd like to see him bring that back, or at least an option where you could turn it on or off. I think the reason they do that is because it drives people crazy when you're going around a board testing a whole bunch of diodes and somebody's next to you and maybe a cube or something. They're just hearing chirp, 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 chirp. But there you go. So if I touch this one, the emitter, so, okay. So that's how the diodes work. All right, let's do capacitors. Now, I'm going to start off with a big old 10 millifarad, 10,000 microfarad audio type capacitor, okay? So put the black on the black lead here. Okay, I'm going to hold that, and then I'm going to touch this down. See how long it takes. Okay, I think... Okay, there we go. So 8988. And I think that's kind of what I remember. This is kind of around that 9,000 range. So, okay, diode. Let's go. Whoop, I passed up capacitor again. Okay, there's capacitor. Okay, let me hold this here. Okay, ready? Touch. Just like see how long it takes for a big capacitor. I kind of slid on it there. And 8949. So yeah, very close. So yeah, there you go. There's capacitor readings, and you see all the extra digits you get. So yeah, there we go, guys. Like to short them out. And by the way, this is good for that 10 millifarad. That's why I think the first time it said DISC or disconnect, or I don't know what that means, but it could be that the first time it saw it, thought it was too much, too big, because it says it's good for 9999. Okay. Millifarads, where this guy's good up to 60 millifarads, 60,000 microfarads. So that's really nice. All right, let's look at a small capacitor for fun. It's not real small, but smaller. Just show you what it looks like. Okay, so 3 digits, 514. Let's do that one more time. 540. Sometimes you have to wait a minute, but I don't know. It's also me moving around probably. So 513 nanofarads, okay? Short that out. So very fast. The small capacitors are really quick because it only has to charge up a small capacitor. So it makes sense. All right, guys, the other thing I want to show you is I have these really high precision resistors, okay? So 10 ohms, we'll just plug in this guy, just see if it's how close it is. Okay. Now let's try this guy first. Oops, let's go to ohms. There we go. Now, sometimes, because these are so rigid, it's nice that these meters, you know, actually fit this standard. But the other thing is, because of the way the blades square off, sometimes I find that if you don't get it just right, you know, like right there, it's 10 ohms. But let's try it. Okay, 10 ohms, so very good. Okay, so I can tighten them too to make sure they're tight. Okay, let's try this one. Okay, 99.9. Try to see if I can wiggle it around. It's 100 ohm, so. And we'll try this guy. Perfectly 100 ohms. And just prove what resistance, because, okay, 100.06, all right? So, all right, so let's try the next one, 10K. $99.6, 99.7, whatever, okay? Wow, look at that, perfectly 100K. Okay, 99.76, I mean, wiggled a little bit. All right, there we go. And one last one, 10K. Seems like it's always just a small fraction smaller. And look at that, dead on 10K. And pretty close dead on 10K, right? We just got extra digits. Hey guys, I almost forgot I have this high resistance meter, okay? 6 meg. Let's just see. Look at that, 6 meg even. And 6 meg even. It kind of teeters back and forth. I don't know if that's me or not. Okay, so there we go. Hey guys, the other thing I want to show you is here's AC voltage, right? Oops. And go over here to AC voltage, just show you that. But what I want to show you is that you can go to Hertz. So you go over here to Hertz and you can read Hertz, all right? And I can push down and show duty cycle too, all right? So just want to show you that. So on this guy, I got Hertz, okay? Now, this thing's reading a little bit on the low side for some reason. And duty cycle, 30%. Yeah, that should be 50%. So I'm not sure what's going on here. I wonder if it's because my battery has been on for a little bit. And yeah, I don't know. Maybe when the battery symbol's on, accuracy drops. See, this guy doesn't, he has Hertz, right? Here, let's go that. Look, he's a little bit off too. So, all right, guys. So I think in the low voltage, it might be because the voltage is so low that if I go to Hertz here, I get the right Hertz. It should be 500 Hertz. So it could be the voltage is low and these guys, yeah, I'm not sure about that. Let's change. Yeah, and it should be about 50%. So that seems right. But if I go to AC, the volts are, yeah, that's off. That's weird. So it could be because of the level of volts. All right, so we're back to volts here, okay? I'm gonna go to frequency and we're gonna go to, I'm going 900 Hertz. There's 1,000 Hertz. That's where the meters are, these two meters are spec to is 1,000 Hertz. There's 2,000 Hertz, so 3,000. So you can see they're starting to drop out. The Redfish has, the filter on it is much sharper than this guy. So that's interesting. So there's 1,000 Hertz. Now what if I go down to 100 Hertz? And then try this again. See, it's not even reading it now. Yeah, so it doesn't like that. But if I go here, I can see the 100 Hertz. And 50%. And this guy, I get 100 hertz. So that's interesting. The low signal levels, you got to be up here. All right, guys, if I'm at 1 volt, I can get the hertz correct. So duty cycle correct. We don't have duty cycle here. So, okay, so this guy's correct now. So interesting. 1 volt is all it takes to get. Okay, then I'll pop it up to 100 volts. Okay, we're at 100 volts. Well, I mean, my power supply actually says 96.5, even though I punched in 100. I think it has to have a load on it. But anyway, yeah, 60 hertz. Oh, let's go back to hertz. 50% and 96.6. So, interesting. Oh, you know, one thing I want to show you with my shop lights on and everything, I'll just go turn on the display. Okay. Whoops. That's a double function, hold and light. So there you go. Yeah, I got to point out they do both have hold function where they just freeze the display. This has relative where I can zero it out, and then it folds changes. Like, let's say if I go to 120, 129, I just punched in by accident. Anyway, so it goes up by 28 volts. So, and then the manual ranging. And so, yeah, that kind of shows and I should show you the data log function. All right, guys, this looks like a nice setup. You know, I'm kind of wondering if you damage these, if you remove this, I'm assuming you can repair this. So that's pretty cool, because I do like this case here. Common, red, so it makes it real easy to see. Some of them, they're not colored and you have to look close. Okay, let's go there. Temperature. Okay, we're in Celsius. Okay, function gives us Fahrenheit. Pretty warm today. Okay, Celsius. So yeah, you get temperature with this guy. All right, so let's see us connect. Now, one thing I want to mention is I left that blue symbol on all the time. That probably wears on the battery. Might be why my battery thing's on, plus thing's been sitting around for so long. But anyway, probably should turn that off by hitting this. Okay, you got to accept stuff always. Hey, look, we got temperatures and, oh, we're not plugged into anything yet. Connection failed. Hold on a sec. Let's get something reading. All right. Well, okay, I think it's already added the tool. Okay, I think it's already reading. I think it was asking me if I want to add another tool because it already had this one signed up. So I'm going to turn on the backlight display. By the way, this one stays on for a long time. Here, let's just turn on the voltage so you can watch the graphing action going on. Okay, we dropped down 2 volts. Had a message come up on my screen. Okay, just kind of flipping around different voltages here so we can see a graph. Just went through a bunch of different voltages on my screen. Yeah, so pretty cool, right? And now we can hit record. It'll record all that stuff. Okay, record, stop, whatever, and then we can expand the screen, shrink it so we can see this. There's a toolbox, don't know. Okay, text, whole bunch of different, oh yeah, there's a whole bunch of different tests that are programmed in here that you can do. Pretty cool, right? Hey guys, thanks for sticking out this long. I want to give 2 thumbs up to my patrons, my YouTube members. Really appreciate you guys supporting the channel. Redfish did send me this out for free. They sent me this one out and I kind of forgot about it, left it in the box, because this is the one that we talked about me reviewing. And then they just thought, heck, we'll send you one of these out. which was super nice of them. Appreciate it. Thanks, Redfish. And it's an awesome meter, but I just kind of forgot about it. Kind of got buried, and I've been pulling things out of boxes so I can sell things, get rid of things. And, you know, as a matter of fact, I got 2 more of these I got to sell. My wife's selling brand new in the package. My wife's got an eBay channel. She's selling stuff. So send me an email if you're interested in scopes or any kind of equipment, power supplies, meters. I might even sell this, I'm not sure, but I probably will, just because I got too many meters. But I love the, you know, this guy for just less money than this one. Now this one thing I didn't point out is that it does have low Z for phantom voltages or the ghost voltage, so that is a nice feature. This guy has the Bluetooth and the data logging, which is huge. Usually you find that in more expensive meters. So that is a huge feature. Plus it has milliamps and microamps. So if you're doing instrumentation readings, that might be more helpful for you. It does duty cycle as well. It's got a lot of features, right? It reads really large capacitors too. So a lot larger than what this one would go to. So I think it's 60 millifarads versus 10 millifarads. There you go, guys. What do you think? Let me know if you like the larger display, the larger digits versus this. Hey, and let me show you the display backlight from that far. Now, by the way, this battery is flashing at me because I left that Bluetooth on for a while now. It's actually taken me a while to do this video. So, yeah, so what do you guys think? Which one do you like? From close up, this guy here is more evenly lit and a little bit brighter than the Fluke. The Fluke's got some hot spots, but can you tell from there? This guy's turning off sooner just because it's trying to save the battery. So that's a good feature, I guess, right? Well, there you go, guys. And by the way, this is a really nice clamp on. It has the power measurement, so do power factor and stuff like that, inrush current. So, and there's other meters that do that, right? But this one, in comparison, is pretty low cost. So I'm going to do a clamp-on meter kind of shootout. I've got a bunch of clamp-ons I want to review, and then we'll do a shootout at some point just so I can show you those. But let me know what you guys think. Do you like it when I compare it to a known meter so that you can kind of see it, how it behaves in comparison? It takes a little longer for the video. Appreciate the thumbs up if you like that. But thanks for watching, guys. Happy Labor Day. That was last weekend. I went away, and music festival is awesome. Went to Colorado with family and friends, and that was amazing. I needed the time off because I've been working tons of hours. So thanks for watching, guys. Thanks for being here and sticking it out through the whole video. Appreciate that. Have a nice weekend. We'll catch you later.